In the previous video, we discussed the heat equation and used the formula for the solution of the heat equation. And in this video, we're going to do the same thing for a different differential equation called the wave equation. So in the wave equation, you have some string which starts at x equals 0 and goes out to x equals L. So here's x equals 0, here's x equals L. And it's plucked. And it's held at height 0 at the ends. But it's plucked or moves in some way, and the question is to find the formula for the displacement. So basically here's x equals 0, here's x equals L, and at x equals L and x equals 0, the displacement is 0 throughout for all time. But at other values of x, you have some displacement, which is not 0. So this length, this height will be u of xt. So u could be positive or negative. And the question is to find a formula for the displacement of the wave at position x and time t. So it turns out that u of xt satisfies a certain differential equation, which is that the second partial derivative with respect to time, so that's u sub t, is equal to some constant, alpha squared, so some positive constant, times u sub xx. So the u sub xx is the second partial derivative with respect to x. So this holds for x between 0 and L, and t positive. And in this scenario, we're assuming that the displacement at x equals 0 and x equals L is just 0. So the endpoints aren't moving at all. So that would mean that u of 0t is 0, and u of L of t is 0 for all t. Okay. And that's the basic setup. So this first equation, that's called the one-dimensional wave equation. This equation. The one-dimensional wave equation. There are wave equations for different dimensions. So if instead of a piece of string, you have a piece of the top of a drum or something, right? That has a vibration. So that would be two-dimensional. But for us, we're just interested in the one-dimensional case. So when you have these two equations, again, I'm not going to explain how we get this in this video, but it turns out that the solution is u of xt equals the sum from n equals 1 to infinity of a sub n cosine n pi alpha over lt plus b sub n sine n pi alpha over lt. This t is inside the cosine and sine. This times sine n pi x over L. Okay, so this whole thing is being summed, right? You have this whole term, this product being summed from n equals 1 to infinity. So here the alpha is given by this alpha squared, right? The L is the length of the wire, and the ANs and BNs are just arbitrary constants. So that's if you have these two equations here. But we will also specify an initial position and initial velocity. So suppose that u of x0 is f of x, and also that u sub t of x0 is g of x. So this u of x0, that is the initial position of the string. And the u sub t of x0 is the initial velocity of the string. Right? It's the derivative with respect to time. So it's the rate of change with respect to time. That's the velocity. So once you do this, basically you take your u of xt and you plug in t equals 0 and match it with f of x. Well, you can actually see what's going to happen. When you plug in t equals 0 in here and here, the sine part is just going to be 0. So the bn's are just going to go away. And the cosine of n pi alpha over L times t is just going to be 1. So this first equation is going to tell you that the ANs are given by f of x, which you specify, is equal to the sum from n equals 1 to infinity a sub n sine n pi x over L. So once you know what your f of x is, you will be able to figure out what the ANs are. And then if you do the same thing where you take the partial derivative, u sub t, and then plug in t equals 0 and set that equal to g of x, I'm going to skip that step. But it turns out that if you do that, then you get that the bn's are given by g of x equals the sum from n equals 1 to infinity of sine n pi x over L times, actually I should write this other term first. It's the sum from n equals 1 to infinity of n pi alpha over L b sub n times sine n pi x over L. So once you specify the g of x, that's the initial velocity, then you can use this to figure out what the bn's are. Okay? So let's look at an example. So solve the wave equation above. U sub tt equals 4u sub xx, where x goes from 0 to pi and t is positive. U of 0 t equals u of pi t, which is 0. U of x0 is sine 3x minus 4 sine 10x. And u sub t of x0 is 2 sine 4x plus sine 6x. So we have this general solution that satisfies the first two equations. So we first need to find what alpha and L are. Well, remember that the constant in front of the uxx is alpha squared. So alpha is going to be 2. Okay, alpha is going to be a positive number. Where does the alpha show up here? Okay, alpha shows up in the cosine and the sine. Let's see. I think the thing is that if you use the negative possibility for alpha, then your bn's will just be minus what they would be if you use the positive alpha. So let's just use the positive alpha equals 2 and L equals pi, right? Because x goes from 0 to L. So now we plug in, well, actually, we already sort of did plug in these conditions, right? Because these conditions, u of x0 equals f of x and u sub t x0 equals g of x, told us these equations for f of x and g of x in terms of the bn's and an's. So we can use this to figure out what the an's and bn's are. Okay, so f of x is the sum from n equals 1 to infinity. So now you plug in, for the f of x, your, let's see, there's no alpha here. You just plug in L equals pi. So you get an sine of nx. That's being summed from 1 to infinity. And then our f of x in this problem is given to us. So we know that this is equal to sine 3x plus minus 4 sine 10x. So we can see right away what the an's are going to be, because there's going to be an a for n equals 3, and there's going to be an a for n equals 10. So we're going to get a sub 3 equals 1. That's what's being multiplied by sine 3x. And then a sub 10 is negative 4, because that's being multiplied by sine 10x. And then all other an's are going to be 0. So those are the an's. Okay, what about the bn's? So a sub 3 is when n equals 3, a sub 10 is when n is 10. Okay, what about the bn's? Well, we are given that g of x equals, so we go back to this equation and then we plug in L equals pi and alpha equals 2. So that's going to give us that g of x is the sum from n equals 1 to infinity of 2n bn sine nx. And in the problem, we're given the g of x here. The g of x is 2 sine 4x plus sine 6x. That's a 6. So when you match this part with this part, you can see when you look at the sine nx's that there's going to be two n's that give you non-zero b sub n. That's n equals 4. When you look at n equals 4, you get 2n bn. That's 2 times 4 times b sub 4 equals 2. So that's going to give us that b4 is equal to 1/4. Did I do that right? Let's see. Let's check, because it doesn't match what I have in my notes. In my notes, I said b4 is a half. Okay, let's check n sub 4. So 2n b sub n sine for x let me make sure. So alpha is 2, L is, so it's 2n. Yeah, I think I just made a mistake in my notes. I think this is correct. I think b4 should be 1/4. So, okay, b4 is 1/4, and then the last one's when n equals 6, so I get 2 times 6 times b sub 6 equals 1. So that's going to give me b sub 6 is 1/12. and then all the other bn's are 0. So now we have everything that we need to tell us what u sub xt is equal to, right? Because what are the n's? So when you look at the formula here, there's an infinite sum, but in reality, the only n's that will give you non-zero an's or bn's are n equals 3, n equals 10, n equals 4, and n equals 6. So we just need to write out those 4 terms. So let's write out the term for n equals 3. Okay, so for n equals 3, we end up getting that a sub 3 is 1 and b sub 3 is 0, right? So now we look back at the formula and we just copy down what you get. And when you copy down what you get 3 cosine 6t times sine 3x. Then for n equals 4, you get 1/4 sine 8t times sine 4x. Then for n equals 6, you get 1/12 sine 12t times sine of 6x. And then for n equals 10, you get -4 cosine 20t times sine 10x. Okay, because n equals 3 and n equals 10, those give you the cosine times sine. And then the bn's, when n is 4 and n is 6, they give you the sine nt times, they give you the sine 2nt. What do they give you? Sine 2nt times sine nx. Right? Because you have the 2 because alpha was 2. That's the difference. Because when you substitute, in this example, when you substitute n equals, let's see, alpha equals 2 and L equals pi, you get 2 nt for cosine, and then for sine, you also get 2 nt. But then for the sine n pi x term over L, you just have L equals pi, so you just get sine nx. Okay. So yeah, this is correct. So the u of xt is just what you get when you add all these together, right? So the answer is that plus that plus that plus that. So that's the u of xt. That's the answer to the problem. So that's an example of applying the wave equation formula. Again, we didn't go over how you get this formula for the u of xt. It uses a technique called separation of variables, which is used in partial differential equations. Another thing that's worth knowing is that here the f of x and g of x, just like for the heat equation problem, your f of x, the general formula is given in terms of sines, a sum of sines, and g of x is also a sum of sines. So if in this problem your f of x and g of x are given as a sum of sine functions, then it's pretty easy because you can just figure out what the constants a sub n and b sub n are just by matching the terms together.